In this video, we will understand what is limit at infinity. Limit at infinity is of the form limit fx as x approaches positive infinity or limit fx as x approaches negative infinity. In limit fx as x approaches positive infinity, x takes positive values no matter how large, and we write x approaches positive infinity. In limit fx as x approaches negative infinity, x takes negative values no matter how small, and we say that x approaches negative infinity. Let us understand all this in details. Consider limit x square as x approaches positive infinity. Let us assume x equals 100. So x square will be 100 squared, which will be 10,000. Now let us increase the value of x and assume x equals 10,000. So x square will be 10,000 squared, which will be 8 zeros next to 1. We observe that as x takes higher and higher positive values, the limit x square as x approaches positive infinity becomes infinity square, which ultimately be an infinity. Now let us consider limit x cube as x approaches minus infinity. Let us assume x equals minus 10. So x cube will be minus 10 cube, which will be minus 1000, because cube of a negative quantity is negative. Now let us reduce the value of x still more. Let us assume x equals minus 100. So x cube will be minus 100 cube, which will be 6 zeros next to minus 1. Here we observe that as x takes lower and lower negative values, the limit x cube as x approaches minus negative will approach to minus infinity cube, which ultimately will be minus infinity. Consider limit 1 over x as x approaches positive infinity. Let us assume x equals 10. So 1 over 10 will be 0.1. Let us increase the value of x and assume x to be 1000. So 1 over 1000 will be 0.001. Let us increase the value of x still further and make it 100,000. So 1 over 100,000 will be 0.5 zeros before 1. Here we observe that as x takes higher and higher positive values, 1 over x takes lower and lower positive values and approaches 0. Therefore, limit 1 over x as x approaches positive infinity will be 1 over infinity, which will be 0. Now let us try to understand all this through the graph of fx equals 1 over x. When x takes smaller positive values, 1 over x is relatively large. As x takes higher and higher positive values, 1 over x takes lower and lower positive values. See here, lower and lower positive values and approaches 0. Now consider limit 1 over x as x approaches minus infinity. Let us assume x equals minus 10. So 1 over minus 10 will be minus 0.1. Let us reduce the value of x and assume it to be minus 1000. So 1 over minus 1000 will be minus 0.001. If we still reduce the value of x and assume x equals minus 100,000, then 1 over minus 100,000 will be minus 0.5 zeros before 1. Here we observe that as the value of x goes on reducing in the negative direction, the value of 1 over x goes on increasing towards 0. Therefore, the limit 1 over x as x approaches minus infinity will be 1 over minus infinity, which will be 0. Now let us try to understand all this through the graph of fx equals 1 over x. When x was minus 10, 1 over x was minus 0.1. See here, when x was relatively higher negative value, 1 over x also was relatively higher. As x takes values or x takes lower and lower negative values, 1 over x takes higher and higher negative values, which means the graph of 1 over x is approaching towards 0. We will try to remember two useful limits at infinity. The first one is limit 1 over x as x approaches plus minus infinity equals 0, and second, limit of k as x approaches plus minus infinity, where k is a constant, is k itself. Find limit 3 minus 5x minus x to the power 5 as x approaches negative infinity. Here we observe that the highest degree term is minus x to the power 5. Therefore, the limits of 3 and minus 5x as x approaches minus negative become insignificant compared to the limit of minus x to the power 5 as x approaches minus infinity. Therefore, in the next step, we will omit these two terms. So we will omit 3 minus 5x from the function. So our limit becomes limit minus x to the power 5 as x approaches negative infinity. In the next step, we will put x equals minus infinity. So it will become minus of minus infinity to the power 5, which will be minus of minus infinity, because the odd power of a negative number is always negative. Now negative into negative will become positive. So the answer will be plus infinity. Now solve another limit x to the power 4 minus x cube minus 3x plus 2. In this function, the highest degree term is x to the power 4. Therefore, the limits of minus x cube minus 3x plus 2 as x approaches negative infinity become insignificant compared to the limit of x to the power 4 as x approaches negative infinity. Therefore, in the next step, we will omit these three terms. And write the limit as x to the power 4 as x approaches negative infinity. We will put x equals negative infinity. So it becomes negative infinity to the power 4, which will be positive infinity. Because we know that even power of a negative number is always positive. Let us solve limit 7x square plus 5x minus 3 divided by 8x square minus 2x plus 7 as x approaches infinity. Here, there is a polynomial in numerator and the denominator. Such functions are called as rational functions. Now the degree of the polynomial in the numerator is 2 and that in the denominator is also 2. So this is a rational function wherein degree of numerator equals degree of denominator. Now, in order to solve this limit, we will solve this first by traditional method and then solve it by a shortcut method. For traditional method, we have to divide numerator and denominator by the highest power terms in the function. Here, in this function, the highest powered x term is x squared. So we will divide each term of the numerator and denominator by x squared and write the next step as after cancelling the term, we get the limit as see here, x square gets cancelled with this x square and what remains is 7. This x will get cancelled with 1x from x square and we get 5 over x. Minus 3 over x square will remain as it is. In the denominator, x square gets cancelled with this x square. What remains is 8. This x will get cancelled with 1x from the denominator and what we get is minus 2 over x. And 7 over x square will remain as it is. Now we know that limit of 1 over x as x approaches plus or minus infinity is 0. Therefore, the limits of 5 over x, 3 over x square, 2 over x and 7 over x square will become 0 each, and that we will write in our next step. See here, the limit of this and this as x approaches infinity will be 0 each. So in the next step, what remains is 7 over 8, which is the limiting value of this limit. Solve limit 7x square plus 5x minus 3 divided by 8x square minus 2x plus 7 as x approaches infinity. We have solved the same limit by the traditional method, that is by dividing x square in the numerator and the denominator. This is a rational function where degree of numerator equals the degree of denominator, which is 2 in this case. Now, here the highest degree term in the numerator and denominator is x squared. Therefore, the limit of the lower degree term, that is 5x minus 3 and minus 2x plus 7, as x approaches infinity, will be insignificant compared to the limits of 7x square divided by 8x square as x approaches infinity. Therefore, in the next step, we will ignore these insignificant terms. See, we have ignored the insignificant terms, and after this, we will write limit 7x square divided by 8x square as x approaches infinity. After cancelling x square, what we get is limit 7 over 8 as x approaches infinity, which will be 7 over 8 itself. Now, if we observe the answer and the function, we will find that the answer 7 over 8 is the ratio of the leading coefficients of the highest powered terms in the numerator and denominator. So from this we can draw an inference. Accordingly, the limit 7x square plus 5x minus 3 over 8x square minus 2x plus 7, where the degree of numerator equals the degree of the denominator, we can directly write the answer as the ratio of the leading terms of the highest powered terms in the numerator and denominator. That is, the answer will be 7 over 8. Solve limit 8x minus 6x to the power 6 plus 7 divided by 3x squared minus 15x cubed minus 9 as x approaches negative infinity. This is a rational function. The degree in the numerator is 6 and the degree of the denominator is 3. In this case, the degree of numerator is greater than the degree of denominator. Next, the limits of 8x plus 7 in the numerator and limits of 3x square minus 9 in the denominator become insignificant compared to the highest degree term minus 6x to the power 6 in the numerator and minus 15x to the power 3 in the denominator as x approaches minus 8. So therefore, we ignore these insignificant terms in our next step. See here, we have ignored these insignificant terms from numerator and denominator. So in the next step, we can write limit minus 6x to the power 6 divided by minus 15x cubed as x approaches negative infinity. Now, minus 6 divided by minus 15 will be 2 by 5, and x to the power 6 divided by x cubed will be x to the power 6 minus 3, that will be x cubed. So let us write 2 over 5 limit x cube as x approaches minus 8. Now we will substitute x equals minus 8 in order to solve the limit. So in the next step, we have minus infinity cube, which will be minus infinity, because the odd power of a negative number is always negative. From this, we can draw an inference that in case of limits like this, wherein the degree of numerator is greater than denominator, the limit is always plus minus infinity depending upon the power of x and the sign of infinity. Solve limit 3x plus 20x to the power 7 plus 7 divided by x square plus 5x to the power 5 minus 9 as x approaches infinity. This is a rational function. The degree of the numerator is 7 and the degree of the denominator is 5. This is a rational function with degree of numerator greater than the degree of denominator. Moreover, the limits of the lower degree terms 3x and 7 in the numerator and x square minus 9 in the denominator will be insignificant compared to the limits of the highest power terms x to the power 7 and x to the power 5 as x approaches infinity. Therefore, in the next step, we will ignore these insignificant terms. See here, we are going to ignore these insignificant terms and write our limit as 20x to the power 7 divided by 5x to the power 5. Now 20 divided by 5 will be 4, and x to the power 7 divided by x to the power 5 will be x to the power 7 minus 5, that is x square. Next, we will substitute x equals infinity. So we get 4 times infinity square, which will be infinity. Solve limit minus 7x square plus 5x minus 3 divided by 8x square minus 2x cube plus 7 as x approaches negative infinity. This is a rational function. The degree of the numerator is 2 and the degree of the denominator is 3. This is a case of rational function in which degree of numerator is less than degree of denominator. For finding its limit, first we will ignore the insignificant terms from the numerator and denominator and write the limit as minus 7x square divided by minus 2x cube as x approaches negative infinity. Now minus 7 divided by minus 2 will be 7 divided by 2, and x square divided by x cube will be 1 over x. So in the next step we will write 7 divided by 2 limit 1 over x as x approaches negative infinity. Now we have already learned that this limit is 0. So in the next step we will write 7 over 2 multiplied by 0, which will be 0. So from this we can draw an inference, which is for the limits of the type where the function is a rational function in which degree of numerator is less than degree of denominator, the limit is 0. Solve limit under root x square plus 3x minus x as x approaches infinity. This function contains a radical term. Generally, whenever there is a radical term in the function, we multiply the numerator and denominator by its conjugate. Therefore, in the next step, we will multiply numerator and denominator by its conjugate, that is under root x square plus 3x plus x divided by under root x square plus 3x plus x. In the next step, we will carry out the product in the numerator according to the identity that we have a plus b multiplied by a minus b is a squared minus b squared. So in the next step, we will write square of under root x square plus 3x will be x square plus 3x and square of x will be x square. Here x square minus x square will be 0, and in the next step we will write 3x divided by under root x square plus 3x plus x as x approaches infinity. Now we will take x square common from the two terms in the radical, so we will get x square in bracket 1 plus 3 over x. In the next step, we will write (3x) divided by x, because under root x square will be x, which we have written outside the radical sign. Now this x will get cancelled, this x, and in the next step we will write 3 divided by under root 1 plus 3 over x plus 1. In the next step, we will substitute x equals infinity. So we will write 3 over infinity. Now 3 over infinity will be 0, 1 plus 0 will be 1, root of 1 will be 1, so 1 plus 1 will be 2, so the answer will be 3 over 2. Let us get acquainted with a formula limit sin x over x as x approaches plus or minus infinity is 0. Let us not get confused with a similar formula limit sin x over x as x approaches 0 equals 1. Now we will solve limits based on this formula. Solve limit sin phi x over x as x approaches infinity. Now we need phi u here. So in the next step we will write sin phi x over phi x multiplied by phi. So in order to cancel the effect of this phi u, we have multiplied by phi u here. In the next step we will write 5 times limit sin phi x over phi x as x approaches infinity. Limit of this part will be 0 according to this formula. So in the next step we will write phi into 0, which will be 0. Next, solve limit sin phi x cube over x square as x tends to infinity. Now here we need 5x cube below sine 5x cube. So for that we will write, or we will multiply this function by 5x divided by 5x. So in the next step we will write sine 5x cube divided by 5x cube. See here, x square into 5x will be 5x cube, and this 5x will remain as it is. Now we will write two separate limits for this. This is the first limit and this is the second limit for this. Now the value of this limit will be 0 according to this formula. So in the next step we will write 0, and limit of 5x as x approaches 0 will be, by putting x equals infinity, it will be 5 into infinity, which will be infinity. Now 0 into infinity will be 0, and that is the answer. Solve limit e to the power 3x as x approaches infinity. Here we will substitute x equals infinity in this function. So we get e to the power 3 into infinity, which will be e to the power infinity. Now e is a positive irrational number whose value is 2.7182, etc. And infinite power of a positive number will be infinity. This is the answer. Next, solve limit e to the power minus 3x as x approaches infinity. First, we will write the limit as limit 1 over e to the power 3x, because e to the power minus 3x is same as 1 over e to the power 3x. Now we will substitute x equals infinity in this function and write 1 over e to the power 3 into infinity, which will be 1 over e to the power infinity. Now e being a positive irrational number whose infinite power will be infinity, and 1 over infinity will be 0. So this is about limits at infinity. Hope you liked this video. If you did, please click like, share this video to the needy, and subscribe this channel. Thanks for watching and have a nice day ahead.